All right, so here's a standard outlet. The cover was removed because painting is going on. Typically you would have your cover on here, okay? So you don't typically want to see this without a cover. Also, on the inside of this, there is a metal box in there, all right? So this outlet is exposed on these screws where it goes in. You don't have to do this, but a rule of thumb for me is if I have a metal box in there with an outlet going in, I usually take electrical tape and I'll wrap it over the screws and everything where the wires tie in. So that way when it goes into the box, you don't risk it kind of pushing this way or that way and arcing off of the inside of the metal box. That's why you'll see a lot more of the blue plastic boxes and things like that people use to prevent that from happening. But to show or demonstrate a no contact tester, here's a typical outlet. It's red because it's an emergency outlet. It may look like it's hung upside down. It's not really. Outlets used to be hung with your two larger vertical slits up, your ground was down. This way, as a plug pulls out, okay, your ground is staying connected. Okay, so you're still grounding out. You have a better chance of that staying in place. So that's one of the reasons that they're shifted to hang them this way. On these outlets, we have 3 holes, okay? The smaller vertical is always your hot. The larger vertical is always your neutral. This circular type one is your ground. This no contact tester is a high-low voltage, so it's got an HL on it, okay? So up here it says H, below it is L, then it has its power button. So I hit the power button, it's on. I hit for the high-low, okay? And we'll see what it tests for here. Your light goes on. If I stick this in, it's telling me it's high voltage, okay? That is in my hot. All right, now this is called a no contact tester, all right, but obviously you can see contacts being made, but if you get close enough, you don't have to connect to it to be able to read voltage. But this is the interesting part. See, when you put this in here, it's reading high voltage, and anything after 12 volts with this is high voltage. 12 volts and below is low voltage. But when I do the no contact test and I come out near where that hot is hooked in, okay, it's reading low voltage. Why is it reading low voltage? Because I'm not directly connected to it, so it's not giving me a true reading. These are made to be able to find, you know, if electricity might be on or something, but these are not made to fully diagnose. So you could have low batteries in this. You could be sticking this over here. Now see how I put that in the neutral? I have that in the neutral. I'm not getting a reading, all right? I put it over in the hot, I'm getting a reading. So where somebody can go and do something wrong with this is they can walk over, right? Put this in the neutral, thinking that it could go in either vertical. And again, what is the neutral? The longer vertical. They can put this in there and they can think there's no power. Now I can safely take this outlet out and replace it or whatever I have to do with it. And that's how accidents happen. No contact tester they call it, but here we're directly plugged in there. I'm getting my high voltage. I know that's hot, okay? I go to the lower one. It's the same thing. Odds are this and this are connected. Not always, okay? So don't ever just walk up and if you go, well, hey, I know that the shorter vertical is the hot. I'm gonna put this in here. Okay, it's hot. Or you may find that you put it in the lower one, right? And this has inside it right here, and it's difficult to see, but right here, okay, is a piece of metal that is connecting the top to the bottom of this outlet. If you break that metal, This one and this one aren't connected, which means you could wire them separately, which means you can have an outlet that's on all the time, and you can have another one that operates off of a switch. So if you go and you put this in here and it wasn't giving you any electrical signal, it could be on a switch. And you could start taking this apart, and somebody over here could turn a switch on, and you're gonna have a bad day, okay? So you always wanna make sure that you go in the small vertical and you test them. Now, here's the other thing. If you go into that small vertical and you test them and you get no power, you're not done. Go and put it in the large one then. And the large one is a neutral and you shouldn't get a reading. But don't ever walk up to an outlet and assume that somebody wired it correctly, because they may not have. So you test every single one. If you want to be 100% certain and you want to do it the right way, okay, again, this gets you to the point, it lets you know if power might be on, maybe. The most that you can be certain is by taking an actual electrical meter with its 2 leads, putting them in and reading the actual voltage. That will always, bypass this. This will never bypass a meter. Okay, so you always really want to rely on your meter. Again, this is something to kind of just get you in the area, right? You might plug it in like that and you're hearing the beeping, and if you're trying to find a circuit breaker, you can go over to your breaker box and flip breakers until you hear that go off, okay? Doesn't mean it's 100%, you still want to test it with a meter, but at least it helps you troubleshoot.